Okay, here we go, guys. So 7.6, guys, quiet, please. Remainder and factor theorem. So the theorems might seem a little confusing at first, but as we go through the examples, they'll make more sense. So the factor theorem states that if x minus a is a factor of f of x, then f of a is going to equal 0. So for example, you don't have to write this if you don't want to, but this is a polynomial that I just made up. How would that factor, by the way? X minus what? Hope you guys, I know it's Friday afternoon, but hope you guys can factor. X minus 1, x minus 4, good, exactly. So here's the deal. Is x minus 1 a factor of my polynomial? Yeah, totally, right? So what is a here then? According to this formula, a has to be 1, right? So if I plug 1 into my function, if I plug 1 into that, what do I get as the output? 0, exactly. That's all it's saying, is that if you have a factor of a polynomial, and you write it in the form of x minus a, whatever a is, you plug it into the original function, you get 0. So that's the factor polynomial. And the reason why that works is because a factor, whatever makes the factor 0 is an x-intercept, right? And x-intercept is y is 0, and f of a is y when x equals a. So that's why this makes sense, because these are just x-intercepts. Now, the other one is a little weird, but when we go through example 1, it makes sense. The remainder, when you divide f of x by x minus a, now what if you, what if it's not a factor, right? What if it doesn't factor out cleanly? Then whatever the remainder is when you do the division, or so when you divide by x minus a, the remainder will equal f of a. So let's talk about example 1 here. You're asked to evaluate this, right? So I'm going to do this a couple ways. I'm going to just do it like the way you've been taught before. Just plug -2 straight up, right? If you plug -2 straight up, you have to just be mindful of all the negatives, right? So you get 48 minus 8. Is that right? Yeah. Minus 14 minus 9. If I work all that out, I should get 17, I think. Is that right? Yeah, I get 17. Okay. Now, nothing wrong with that, but there's a lot of computations. We're humans, we can make mistakes, right? Here's a way that might be a little more efficient. What if I do f of x divided by x plus 2? Why x plus 2? Because x minus a, if this is a, right? Then x minus a is going to be x plus 2. Let's work it out. Okay, you bring the 3 down. What happens when you multiply -2 and 3? What do you get? Bring in the -6 and you multiply these two, what do you get? 12. Add these two, you get 10. Keep going. -20. -13. 26. And if you do -9 plus 26, you do get 17. So that's the remainder, right? And right here is f of a. Those are the same thing. That's what the remainder theorem is telling us. Is that if you take a function divided by x minus a, which I did right now, where a is -2, it's the same thing as f of -2. F of -2 is 17, remainder is 17. It's not a coincidence. Those are the same thing. So that's another theorem to be aware of. Now, of course, if this was 0, then this means that x plus 2 is a factor. Then it resorts back to the factor theorem, because f of a would be 0 in this case. So they're kind of tied together, those two theorems. So that's really what's going on with it. But to be honest with you, we're just doing synthetic division and finding x-intercepts. That's really the whole essence of this unit, or sorry, of this section. Let's do a couple more here, and then we'll do the next page. So here you have to find the remainder. Great, find the remainder. So we'll do synthetic division, each case. Now when I do synthetic division, let's start with example 2. What will I put on the outside? If I'm divided by x plus 7, what do I put on the outside? Perfect, good. What do I put on the inside? 1, 5, But I'm not going to stop at negative 14 because that's x squared. Is there an x term? And another, yeah. Bring down the 1, multiply, add, multiply, add. And actually, I think that's, yeah, just get 0, 0. So the remainder, just 0, exactly. And actually, it does come out clean because I could factor out x squared. And I get x squared plus 5x minus 14. And x plus 7 is a factor of it. It's actually x plus 7 times x minus 2. So it does make sense. You should get 0. Next one. We'll switch colors for a bit of contrast. What do I put on the outside?
Negative 3.
Perfect. 1, 1, 0, and negative 10. Bring the 1 down. Multiply. Add. Multiply. Add. Multiply. Add. And there you go, negative 28. So it should be pretty straightforward. Questions? We're good? Okay, cool. Okay. Not a big fan of example 5, but we'll do it. But the example 6 and 7 are pretty fast. So we should be done with these notes in the next like 7-8 minutes, and then you guys can do the quiz after that. All right, well, let's keep moving. All right, write upon a function in factor form. Okay, that's nice. And these are your x-intercepts, right? So my function will be this. X plus 6, x plus 2, x minus 2, x minus 6. That's it. So no need to FOIL because you want a factor form, right? But example 5, that's why I kind of let a huge sigh. So I'm going to start by doing this x plus 3, x plus half, x minus 7. So in this case, it has to be expanded. So you have to FOIL. We have no choice. I know. But let's do this. Let me do a little rearrangement.
Do like x plus 3 and x minus 7.
Yeah, that might be smart.
Do you mind if I
Take a whole bunch.
There's no markers up there.
Oh my goodness. Yeah, go for it. Yeah, let's do that first. Okay. X squared minus 4x minus 21. And I'm gonna make this 2x plus 1. Why do I think I did that?
Yeah, it's easy to work with. It still provides the same x-intercept, right? I just simply just multiply by 2. It means I multiply this by 2, but it's not a big deal, right? It's like, we were told that there had to be a specific leading coefficient. So you actually have full freedom if you want. But 2x plus 1 does make that work, all right? You put it in the path and it works. So I don't think it's a problem.
So then you just gotta multiply those together, which is 2x cubed minus 8x squared minus 42x. And then I'm gonna have positive x squared, negative 4x, and negative 21. 2x cubed minus 7x squared minus 46x minus 21. And there we go. Yeah, just a little extra work. It's kind of busy work. But yeah, just make sure you know if you have x-intercepts, those are factors. X minus those numbers are the factors. So if you have negative 3, it's x plus 3. If you have negative half, it's x plus half, or make it 2x plus 1. If you have 7, it's x minus 7. Questions? No? Yeah, no problem. We're good.
Give us everything that we have.
Yeah, that's just because I decided to multiply x plus half.
So
It's still the same thing because you'd have to factor out 2. And you're or actually no, sorry. Did you have fractions? Yeah, you do have like x cubed minus 7 halves x minus 23x minus 21 halves. It's the same thing. It's the same thing, yeah. It still satisfies the conditions, the problem. Okay. Oh, and hold on, Stella. Let me do this so you can okay, so you got it there, Stella, in case you need to copy it later. All right. So let's keep moving. All right, example 6. This you guys have seen, I think. This is the advantage of synthetic division. If you're told this is a 0, it means it's an x-intercept, right? So we know f of negative 1 is going to equal 0. So I'm going to use the factor theorem, right? I'm going to put negative 1 on the outside, 15, 14, negative 3, and negative 2. Because I expect that to be 0 at the end. Okay? Expect that to be 0 at the end. And I'm just going to go through the motions of synthetic division, right? Let's do it. 15. What do I do next?
Wow.
Yep. 1, negative 2, 2. So it's 15x squared, negative x, negative 2, equals 0. That's why we do it. So in essence, the synthetic division, it's like factoring. It's just like factoring. And then you can factor this further. I'm trying to remember off the top of my head. 5x and x negative. Shoot. I think that's negative 2. No, that's plus 1. Hold on. Yeah, that's it. That'll work. I did it by trial and error. There's other techniques for factoring you can use, like you might remember like doing the diamond or the rectangle. I mean, whatever you prefer, I don't care. But in this case, x will equal 2/5 or negative 1/3. So those are your other x-intercepts, in addition, negative 1. So question on that one? Nope. Okay. And we are going to do stuff with complex numbers next week with this stuff. We're just kind of scratching the surface with finding zeros using synthetic division. Last one. And I don't know why there's a whole page for it, but well, maybe just because we don't want any more examples. We don't have enough room to squeeze in the second page. Same thing again. I'm going to have you guys try it. Put negative 4 on the outside. 2, 7, negative 5, negative 4, 0 at the end. So I'm going to freeze the screen and have you guys try it. Here we go. Here we go. Questions? No, we're good. Cool. Yeah, that's all I do. Very simple. Those are the x-intercepts. Also, negative 4 is an x-intercept. And so the homework for over the weekend will look like this. So yeah, so you got all this stuff here. Yeah, so yeah, it's supposed to work out those functions. You got number 7 there. 5, 6, 3, 4. So yeah, evaluate, find the remainders, break down the polynomial to find the other x-intercept or zeros, and then just fully expand it. And the answer key is already up at Schoology. So that'll be the homework, which you guys can start after the quiz, or if you still want to do it now, you can do it on Tuesday night. It's totally fine. But you know, Spirit Week's coming up, so make it good to get things out of the way. And I think that's it. All right, stop recording.